So welcome everyone to our session on integrating DBT and Apache Airflow with InterSystems IRIS. I'm Herman Bruwer, a sales engineer from South Africa, joined by my colleague Reven Singh, also a sales engineer from South Africa. So let's get on with it. So we're going to first start with a bit of an introduction on the why, then talk a little bit about the how, and then we'll do a detailed demo on the solution. So with that, I would like to hand over to Reven.
All right, thank you, Herman. And yeah, good afternoon, everyone. Thank you for joining. Clearly, you've been let in on the secret that we've saved the best for last. um, before we kick off, I just want to set the scene a little bit. I think we can all agree we're living in exciting times. All the stuff we've seen around AI, Gen AI, it's really something that, um, yeah, I mean, some of us might be filling up the bunkers in case the AI goes rogue, but I think the general sentiment is that there's immense value to be had. There's obviously a fair bit of responsibility in how we use AI and how we build our AI-based applications and things like that. But again, there's immense value to be had. Now, while Herman and I were still in South Africa, we thought we were going to have to convince you that AI is going to be the next best thing. So we went off and put together a bit of motivation. But I don't think that convincing is necessary. So I think we'll just agree. Now, if we have to just think a little bit beyond this, and if we have to think about AI context of um, analytics, I think some things don't change, right? Good AI, good analytics requires good data. And when we think about good data, I mean, there's underpinnings that make up good data, and we'll talk a little bit about that. So one of the underpinnings is effectively your data platform. And again, I'm not going to go into too much detail here because I'm sure you guys have seen amazing demos and presentations all week. But the point really is InterSystems IRIS data platform, great place to build your analytics applications and your AI-based applications. And if you're already using IRIS, then you're already ready for what comes next. Now, if we have to think about our data platforms, it really fits as a component in a bigger picture. And that bigger picture speaks about data governance. And over the course of the past 3 days, we would have heard about things like ethics in the context of AI, security, privacy, regulatory compliance, and things like that. And data governance really talks about what are the structures, policies, and processes that we need to have in place in order to manage our data and get to the outcomes that we're looking for in terms of achieving healthy data that we feed into our analytics and AI-based applications. Now, for those of you who work in data or who have worked in data, you might be familiar with some of the frameworks around data governance. So just to name a few, you may have come across the DMBOK by Dharma, the Eckerson framework. Some of the large consulting groups have their own frameworks that they use. But I think if we had to look for commonalities, there's one thing that really sits at the heart of all of this, and that is data transformation. And when we talk about data transformation, we start thinking about how do I take source data and raw data sitting perhaps in disparate systems, and how do I bring that together in a way such that I can use these as strategic data assets so I can get insights from these. And you'll remember in one of the sessions, it was said that insights leads to discussions and discussions lead to actions. So if we really want to get to actioning things in the way we want to, we've got to look at how we transform our data. Now, just to give you a practical example and draw it back a little bit, if I've got customer data, let's say in a CRM, I've got some billing data and some other billing system, and let's say I've got more customer data sitting in about 3 other systems. The question then becomes, how do I take all of this and look across that data? And the answer is, we've got to take that and transform it somehow. Now, the reason I give you that example is for what comes next, which is this can become extremely complex. Unless you're in healthcare using HealthShare to create some sort of canonical view of your customer, you're okay. But outside of that, there's lots of challenges that we might find ourselves running into. Now, if we had to group these challenges into 3 categories that I want to talk about a bit today. So the first is building, and this is really writing the code to take our data from our source systems and transform that data and get to our joined data sets. And some of the issues we might run into there is code modularity. So if we don't write our code in a modular way, it doesn't become reusable, it becomes difficult to test. We often find documentation might become a bit of an afterthought. It's difficult to track through data lineage to understand what the sources are that lead to a particular data set. And overall, this just leads to inefficiencies in actually building transformations. But let's say you've passed that phase and you've got your transformations built. The next thing becomes, how do I orchestrate my task dependencies? So again, to give you an example, or to draw back on the customer example, it's really important the order of events when transforming our data. So for example, I would need to process my customer data in all likeliness before I process my billing data, and that's just a logical dependency. Now, in a production environment, we got to think about how do we consistently respect that dependency and what do we do if things go wrong. And that also brings us to things like how do we schedule our data pipelines, monitor, handle errors, etc. And then once we've got our engineers able to build transformations, perhaps our administrators able to orchestrate and schedule our transformations, then we'd want to look at, now that we've got all of these moving parts, how do we manage it in entirety? And that might mean managing collaboration across teams. How do we promote stuff through environments? And just how do we get to a solid change management strategy? And I think if we can solve for these 3 challenges, or these 3 categories of challenges, then we'll be in a space where we've got really streamlined data pipelines. And with that, Herman's going to tell you more.
Thanks, Reven. So we'll be looking at DBT and Airflow to overcome these challenges. I think that probably the first question in the audience would be, so why use DBT and Airflow? Can't you write your data pipeline in object script and productions? And the short answer is yes. You can write custom code to do exactly that. But in the enterprise space, a lot of times it's difficult to get object script resources, so getting Python and SQL resources might be a little bit easier. The other part is, in an enterprise space, you also deal with a number of solutions. So you would want to have a pattern and a framework that would fit not only one use case, but sort of a range of use cases. So first on is DBT. It's called the Data Build Tool. Essentially, it's using SQL to do your data transformation in your data warehouse. Now, there's 2 flavors of DBT. DBT Cloud, which doesn't work with IRIS. And then we've got the open source DBT Core, for which we do have a connector. So that when we talk about DBT, we would be referring to DBT Core. Now, DBT's got a concept of a direct acyclical graph, and that is, or helps to visualize your data pipelines and lineage, sort of to show dependencies and relationship with columns and tables. And DBT also allows you to, in your DBT project, to create modularized code that's easy to source control, and as Reven said, aids in. Next up is Airflow. So Airflow is a platform for scheduling and your orchestration workflow in Python, which is also source controlled, which will also make it repeatable. It's got a web interface, so doing some of the configuration, you don't need sort of to know cron or things. It's quite convenient in that aspect. Then it's also got built-in adapters for the likes of Azure, AWS, and Google Cloud, so you can run tasks quite easily out of the box. So, and then lastly, it's also got the concept of a direct acyclical graph, which is sort of the collection of tasks and sort of bringing back the dependencies and relationships to say how things should run. Then Astronomer, which is really a bit of the secret sauce. So you've got DBT DAGs and you've got Airflow DAGs, but they're not the same. And Astronomer or Cosmos allows you to load these DBT DAGs into Airflow without you needing to change anything. Okay, and then sort of lastly, GitHub. So we've chosen GitHub. You can use any CI/CD tool you want. I'm sure everyone is familiar with source control. So we're not going to go into any details of that. So the problems this would really address is in the management space that Reven highlighted. And part of that is collaboration. It enables collaboration. So you might have different teams doing data engineering on DBT, and it will allow you to merge those. And you, at the same time, you might have an administrator doing changes to your workflow. So this will allow for collaboration between these teams. And then obviously ultimately automate your deployment. So streamlining your data pipeline as easy as 1, 2, 3. So first off, you create your DBT project and build your transformations. Then secondly, you create your Airflow DAGs in Cosmos. And then lastly, you build your CI/CD pipeline, and off you go. And with that, I'm going to hand over to Reven.
All right, thank you, Herman. I don't think I need the clicker, so. Okay, so I'm going to show you a demo in a second. Just a few bits before I get into that. So in this demo, I'm going to show you how to go from basically an empty environment, not too empty, but mostly empty, to having something that works as per what Herman described. So creating a transformation, scheduling and orchestration, and managing that using GitHub. So the data we'll be using to create our transformation, DBT Jaffle Shop data, freely available online. It's part of the sample data set provided by DBT. And the objective of the demo is really to see how these technologies can work together. So I'm not going to go into too much detail on each of them. There's lots of resources available online. It's more really just to see how can we use them together and achieve some sort of streamlined data pipeline. Now I'm going to use a pre-recorded demo so that we can go from nothing to something and skip some of the build parts. But we do have a live environment in hand, so if there's anything that anybody wants, we can always look at that. All right. Okay, so I'm using an Ubuntu OS with VS Code. We've got Python installed and Docker, and that's about it. Besides that, we're starting in an empty environment. Now, the first thing we're going to do is create a Python virtual environment. And in that virtual environment, we're going to do a pip install of DBT IRIS, which is the IRIS connector for DBT, and that allows us to work with data in IRIS from DBT. Now, so once we've got that installed, the next thing we're going to do is run DBT init. Now, just a note, I know that's not so easy to see. I do apologize, and I'm going to speak through everything I do. So I think the idea here is also once we're out of the session, you'll get the recording, and if you need to set this up on your own, you'll have the step-by-step, and you'll be able to see it much more clearly on your own screens. But for the demo, I'll speak through everything. Right, so we've run DBT init, which initializes a project. It asks us for a name of the project. We've called ours sales, and what database we'd like to use, and it gives us the option of IRIS. So once we select that, we see that our project gets created, and I've got a pointer. There we go. That's what that structure looks like. Now, the first thing we're going to do once we've created our project is create a connection file. And to do that, we're going to create a new file, and we're going to call that profiles.yaml or YML. And in that file, we're going to define your host name, port, username, password, namespace, and schema. Now, the namespace that I'm going to be connecting to is called Enterprise Data Dev, and the schema that I'll be using is called DBT, and I'll chat a little bit more about that in a short while. All right, so once we've created our profile, we can then test it, test the connection. We can do that by running dbt space debug. And if we're able to successfully connect, then it's going to tell us, like it has, the connections to this namespace has been successful. So now we can go to IRIS, and let's have a look at what that looks like. So again, we're in the Enterprise Data Dev namespace, and if we expand our tables, you'll see that's just completely empty. So that's just to kind of prove that we are using an empty environment. All right, so the next thing I'm going to do is simulate a source system. To do that, I'm just going to import some CSV files into a schema. So to import the files, I'm going to use the DBT seed functionality. So effectively, I'm going to copy a bunch of files and place it somewhere that DBT understands. And the way my project is configured, it's that seeds directory. And we can see that we've got customers, items, orders, products, stores, and supplies. So those would represent our source data tables. Now, just to separate things a bit, we're going to put that in a separate schema called shop. But now the way that DBT works is that the schemas actually concatenate. So in my profiles.yaml file, I specified a schema called DBT, and now I've got a sub-schema of sorts called shop. So the way that this would actually materialize in the database is we'd end up with a schema called DBT underscore shop. All right. Now, in terms of best practices, what DBT recommends is that for each of our source tables, we create staging models that represent these source tables. And in that way, when we're actually transforming our data, it gives us a number of benefits in that we can trace through our lineage. We're not constantly referring to our actual source tables. And it also allows us to do a bit of cleanup when we're actually creating those staging models. Now, you'll recall the source data that I'm simulating is going to be in IRIS. So the first thing I'm going to do is configure a sources.yaml file so that I can define what those tables are in my database. And this is what that would look like. So I'm specifying the name of my source, the various tables that represent my source tables, which is, like we've seen, customers through to supplies. And the schema that I'm going to put in is DBT underscore shop. All right, so once I'm done creating that, then I can start creating my actual staging model. So we're going to start with the customer source table. The staging model we're going to call stg underscore customers, and it's a SQL file. Now we can use an expression, SQL in a form called CTEs, which are common table expressions. And that's really what it looks like. So it allows us to use with statements and write really modular looking code that makes it easy to read, write, and debug. So this is what my stage underscore customers or my customer staging model looks like. The other thing I want to show you here is creating a config file for your model. And we'll name this the same way. So we've got stage underscore customers.yaml. And in this config file, we can effectively we can put in some information about our model, like the name, description. We can also include some data tests for our column. So in here, we're testing that our customer ID column is going to contain values that are not null and unique. All right, and we're going to do the same thing for the rest of our source tables. So I'm not going to go through each of them. I've already created them and I'm going to put them in there. Okay, so that gets us through to our staging models. Now the next thing I just want to show you is macros. Now we often find ourselves having to write pieces of SQL code over and over again to do some transformations. In this case, let's say converting cents to dollars. So if we have a column expressed in cents and we want that to be in dollars, we can create a macro called cents to dollars, put in the SQL code for it, and then we can call that macro when we write our models instead of having to rewrite that line of code each time. And I'll show you what the macro syntax looks like in a second as well. All right. Now, the next thing I want to do is create, so now that we've got our staging models again, we're going to create a model that combines data from across many of these staging models, and that really gives us a joined consolidated data set. So we've got so we create a model called order underscore items.sql, and we can see that we're getting data from the stage underscore order items, orders, products, and supplies, and we're joining that. Now, what I really want to point out in here is the ref. So that's an example of a macro using this curly bracket syntax. Now, earlier I mentioned that dependencies between your processing tasks in a transformation can get quite complex and difficult to manage. This ref syntax automates some of that. So effectively, by using this, DBT knows that in order to run this model or create this model, it depends on a number of other models. So it will create the order such that the other models will run first, and only once those are ready, then it would run this. So it saves you a lot of manual dependency management, if I can call it that. Right, and like we did with the previous models, we're going to create the config file. That's a YAML file. Okay, so once we're done with that, we can go ahead and run it by running dbt run. And we see that it logs the events as it happens, and it's busy creating all of our staging models. And lastly, it creates our order items. So let's go look at IRIS and what that looks like. Right, so back in our namespace that we're working in, we've now got 3 schemas. DBT shop, which is representative of our source data. If we just do a quick select, we'll see that that's now been brought in. We see our staging models exist in our DBT underscore stage schema. And lastly, we'll find our order items dataset or table in the DBT schema. So if we just select that, right, we can see that our transformation successfully run and everything seems to be fine. Now the next thing I want to show you is One of the other functionalities of DBT, which is creating documentation. So if we run DBT docs generate and DBT docs serve, what DBT does is it creates a web-based documentation app for us where we can then go in, and we're going to do that now, and we can view various bits of documentation around our project. So we can see the source that we've defined, we can see the projects that we have. So in the source, it shows us our namespace and things like that. Under our projects, we'll be able to see all of the models that we've created, the macros that we've built. In our models, if we open up one of them, so let's open the order items. If you click on it, you'll see additional information, description, columns, what the model depends on, which is quite important. So you can see that this model requires those staging models, as well as the code. Now you can also see a graphical representation of that lineage, which is quite nice because it allows you to view all the way from your source tables through to your staging models, what that order of events are and the dependencies are in order to get to your final data set. All right, and then so that's really the DBT part of things. Just to do a bit of a sanity check then. Did I overshoot a bit? So if we track back to some of the challenges that we looked at and we look at, what have we actually achieved then, we'll see that it's actually quite a bit. So using DBT, we're able to achieve or write modular code that's reusable. We can easily test, we can generate documentation, view lineage, and overall just achieve greater levels of efficiency in development. Right, now the next thing that we want to look at is, so we've seen how you can run all of this on your machine, but in an actual environment, you're probably not going to do that. You need to be able to schedule these pipelines to run or trigger them to run somehow. And that brings us to the orchestration part of this, which is where we'll be using Airflow. Now, to start off, we're going to create a working directory. I've called it iris-airflow-dbt. And using something called the Astro CLI, which you can easily install, we're going to run Astro dev init, which initializes our Astro project. And then if we expand that to look at what that project structure looks like, this might look quite familiar to some of you. It's very much a container-based project. So what we want to do is we want to include our Python dependencies, which is DBT, IRIS, and Astronomer Cosmos. And I'll talk a bit about Cosmos in a second. So that when our Astro environment is built and the containers are running, these dependencies are available to us to execute in there. All right, so once we've done that, the next thing we want to do is create a DAG. So like Herman mentioned, a DAG is effectively a pipeline. In DBT, it's your transformation pipeline. In Airflow, it's your orchestration pipeline. So we've created a DAG called salesdag.py, so it's a Python file. And this can be a fairly boilerplate activity where you configure what your connection profile is, where your DBT project lives, and some other information around how do you want to run this DAG. So do you want to run it daily? If things fail, how often do you want to retry, and that sort of thing. And that's effectively what a basic DAG would look like. Now, just to note, this is really where Cosmos comes into the picture. The reason why this is all so simple is because Cosmos allows us to point to our DBT project and really translate DBT into something that Airflow can manage. Right, so once we've created our DAG, then the next thing we want to do is copy our DBT project into our Airflow DAGs directory. And that's effectively what you need to do so that Airflow can run your DBT project. So once you've copied, and maybe just to reiterate this a little bit, to deploy your DBT project into Airflow, It's really these two steps. Create your DAG where you configure stuff, and then copy your DBT code into your DAGs directory. Once you've got those two things in, you should be good to go. Right, and then we can go ahead and start it up. So we run astro dev start. Now you'll see there's some containers that are starting up. So we're going to skip that a bit and go straight to the Airflow UI that gets created and shown to you. Now here's the DAG that we've created. You can see there's some additional information. So when it was last run, next run, there's a bunch of quick links to various things. Now we're interested in, so what we're going to do is open up the DAG, and we're just going to look at what that looks like. Right, so we'll see there's some colors going on in the left that tells us about statuses of previous runs. There's a legend that shows us what those colors actually mean. And we can see a graphical depiction of the dependencies between our jobs. Now, this isn't as pretty as the way we've seen it in DBT, but what you can see is that our order items run has maintained the dependencies that we've created. So it will wait for your stage under your orders, your customers, your order items, and your product staging models to complete before your order items actually does. So if we hit run, it gives us a notification that it's about to run, and we see a new column of statuses come up, and they start changing colors. So light green means it's running, and we immediately see a few turn yellow, and yellow actually means it failed, which is good for the demo because now we can go see how we debug stuff. There's a couple of tasks that have run, and if you click on the actual task and if you go to the logs, you'll be able to see a detailed log of exactly what happened. So in here it was completed successfully, so nothing too interesting to report, I suppose. But if we look at one of the tasks that are up for retry, so let's look at the products seed, and if we look at the logs again, we can see the log of the failure. And I mean, we're not too interested right now in why it failed. It's just more that if it fails, you can see what went wrong and you can retry without human intervention, which demonstrates a level of resilience. So skipping ahead to, we'll skip ahead to when the retry actually happens. So you can see some statuses, and then the status of that task turned gray. So it was queued, now it's running. And if all goes well, it's going to turn green. There we go. So now everything's run. The last thing that needs to run is your order items. And again, that tells us that it's maintained the dependencies that we need it to maintain, because everything that order items needed ran first before order items itself had run. Just a few other bits. You can see the code for your DAG in the UI as well. You can also have a look at your task duration that shows you how long your DAG actually ran for, how long it was queued for, and things like that, which is quite useful in trying to determine when your data set might be ready. You can also go back to previous runs and look at the statuses of individual items and the logs for individual items. So it's actually really, really comprehensive in terms of what's available to you to orchestrate, schedule, monitor, and things like that. So again, if we just go back to this and look at what we've achieved, so we were able to create task dependencies, schedule, we can monitor, log, handle errors, and everything's code-based configuration, which is important for what comes next. All right, so thank you for bearing with me so far. I'm almost done. Now, this all probably seems like a lot, but if you've done it right, this is all once-off setup. Because effectively now we go into more of a role-based kind of process where you've got your data engineers and they just work with DBT. You've got your database or your data administrators and they likely just work with Airflow. And then it becomes a matter of how do I build a process that's really easy. So as a data engineer, all I should really be doing is maybe cloning my DBT repository, working on it locally or in a dev environment, checking it back in, and then I should be able to create some sort of deployment process may be triggered by a pull request in this case, GitHub, for example. So to just give you a sense of what we've done, we've split up our project into two repositories, the one that contains our DBT project and the other that contains our Airflow project. So this is a DBT project, and I mean, it just contains what we've just created. And this is our Airflow project. And all I want to point out is, earlier I mentioned that to deploy into Airflow, you've really just got to copy the files in. Now, the way that we've done this here is we've created a sub-module in the DAGs directory. So that points directly to your DBT repository. So again, that achieves what we've just mentioned. As an engineer, all you got to do is, you don't even need to know that Airflow exists for the most part. You can just work in your DBT repository, build your transformations, check it in, and you deploy. And yeah, I think if you have achieved, well, I think to round up, this really shows you how using these technologies together, we can quite cohesively create a really streamlined approach to data transformations and how we orchestrate and manage that. So hopefully I haven't bored you all to sleep. And to make sure I don't, I'm going to stop talking right now and hand back over to Herman.
Zay, thanks, Reven. Yeah. So, no, great stuff. Like I said, 1, 2, 3, as simple as that. Boom. So, there is a bit of a caveat. DBT only connects to one data source. But luckily with InterSystems IRIS, using foreign tables, you can extend that and connect to sort of different systems, and the data of the foreign tables become available. So, and that also plays to the topic that Reven earlier mentioned, the data fabric. So, yeah, so I think just to recap, we've there we go. We've contextualized how using how you can streamline your data pipeline using DBT, Airflow, and in our case, GitHub. And we will share with you the GitHub links. The full sort of demo would be available. Obviously, this would be available. And with that, I would just like to thank you and all for coming to our session and open the floor to questions.
Many questions. The two ones that come to mind first are, is there a graphical environment, low-code environment for visualizing the DBT pipeline? I think we saw a little bit of that for the Airflow. And what tools are in VS Code to help you with the DBT coding, I guess you could call it?
So there is extension for DBT for VS Code.
So it basically helps you with syntax highlighting? Anything else?
Because there is this template in syntax, and it just helps with this. I think it's Ginger, Ginger template. So it just uses it to help with. It doesn't help with names of tables. Yeah, it doesn't get, but at least with something with templating and syntax highlighting. Yes.
Thank you for that, Dimitri. So for those of you who don't know, that was Dimitri, and he's been very involved in the building of the DBT IRIS connector. So again, thanks, Dimitri.
Yeah, thanks, guys. This is very interesting. I've never used DBT before, but I'm curious. You said it really works with one data source at a time. I mean, if I've got several data warehouses, I've got different directories with, I don't know, CSV files, whatever, and I want to run, these sort of data transformation pipelines into a single, maybe, instance of IRIS. How would you orchestrate that?
So I would say foreign tables are a great way to do that.
So DBT is how they name themselves is a ALT. It's a T in ALT. So meaning that DBT itself only for transformation. Where you get this data, it's up to you, but it's supposed to be one source. Foreign tables, one of the ways, but I would offer alternative, like you could connect to Trino or Presto, which can solve this thing, which can can be connected to multiple sources of data, different sources of data, and through this connection, you can connect to any database, including IRIS. I implemented it there as well. So,
Data federator? Is that what you're saying?
I'm not.
Trino?
Yeah, Trino and Presto now supports IRIS as well. I made it too, so you can use them as a single source connector to all of the data. So in this case, you can just add this additionally. I think this should work. Yep.
So just to clarify, if I want to schedule different data transformations on different things and have them projected into IRIS, perhaps through foreign tables, how exactly do I orchestrate these differently scheduled transformations?
So if you've got different transformations, in all likeliness, you'd have a DAG per transformation, and that DAG might have a DBT project with its source connections or its connection really. But you can also bring in other features of Airflow, for example, that can supplement your DAG. So if you want to use some of the connectors in Airflow, let's say you want to notify a channel, for example, once your transformation pipelines run, you can do that sort of thing. But I think there's really that many kind of relationship that exists.
That makes sense. Thank you.
I think you forgot to hit the second part of my question, the low-code interfaces to build the DAGs in DBT.
So I wouldn't say low-code interfaces, but I think it's really highly SQL-based interfaces, and the dependencies are automatically created by using your ref macros. So you're not actually having to go and manually do dependency management between the models you create. And then those dependencies automatically then using Cosmos are then translated into your Airflow orchestration DAGs. And that's really how that flow would work.
Hi, do you have any production site using this kind of pipelines today?
No.
Is it in production?
No, we are talking to customer about this, but we don't have anything at the moment, no.
Thank you all once again.
Yeah, thank you, everyone.